Welcome back, everybody. Now that we've taken an 8-4 little quiz, um, we we're actually going to move into a little bit of chapter 6. Um, just remember that in this crazy time, and we have such a limited number of actual days left, and therefore like a limited number of assignments or lessons I can do. I want to make sure that I get into chapter 6. There was a little bit more. It wasn't like chapter 8 was going to be a huge chapter. There was only going to be like another maybe couple of sections. But, maybe I can squeeze that in the final week or something. But, again, I'm trying to hit the major notes, and I'm trying to prioritize, with the time that we have left. So I'm going to do a very quick lesson on 6-1. Now, this chapter is all about radical functions and rational exponents. I'm not going to talk about this just yet. It's a little too early. But radical, if you ever heard the word radical in math, you would have talked about that before, with like doing a root, like a square root. When you write out, well, right now, when you write the symbol, when you write the square root of like 9, that's a radical symbol. So radical means like roots. Okay, but this shouldn't be that crazy. So here we go. Let's get right in, huh? So roots and radical expressions. So since 5 to the second power is 25, the square root of 25 is 5. Like, you've known that for years and probably understood it for years, that the square root of 25 is 5. But you could also talk about like cube roots or third roots and fourth roots and fifth roots. So the third root or cube root, you can feel free to write that down. That, in other words, like you could say third root, but it's probably more common to say cube root. Cube root of 125, that's also 5, because 5 to the third power is 125. So when you're trying to find like the cube root of 125, you're trying to figure out what number to the third power would equal 125. Just like here, you're thinking, what number to the fourth power would get you 625? Like, in other words, what is the fourth root of 625? And, it says it right here. This is kind of like a little, sort of sequence here, like a progression, right? That's the word I was thinking of, I think. It's also 5. And then, of course, since 5 to the fifth power is 3,125, then that means the fifth root of 3,125 is 5. Another classic example would be the cube root of 8, or the third root of 8 would be 2, because 2 to the third power equals 8. So we're just kind of, in one way you could say, like in this section and a lot of this chapter, this unit, we're just kind of taking square roots to the next level. Like, if you can do a square root, you should be able to do a third root or a fourth root or a fifth root. And so here's a quick definition. Not that I'm going to put a whole lot of stock. It's just basically a very textbook way to say that. So I'm going to move on really quick. And if you want to pause and write this down, it's just sort of like a textbook style definition. So since, here's something important to understand. If 2 is a fourth root of 16, is negative 2 also a fourth root? So this is saying right here that 2 to the 4th power is 16. Is negative 2 to the 4th power also 16? Yeah. Okay. So we're kind of building to a pretty important, like, epiphany type thing, you know. But yeah, I mean, if I said, you know, what are the 4th roots? What are all the 4th roots of 16? You would say 2, and you would say negative 2. Now, you know what? I think I'm gonna executive decision right now. I'm going to stop right there and pretty much get to the point. Okay. Let me explain some nuance specifics here, and I'll even use this again. When you, because this might have confused you a little bit, like this might have struck you a little bit strange. So for years, whenever you are shown this, like with this symbol, this radical symbol, like this right here, is called a radical. So when you see the square root of 25 written like this, or if you think about it or type it into your calculator, the answer is 5. That's it, you know, not 5 or negative 5. So this symbol, okay, this is huge. You might want to write this down right now. This symbol only implies the positive or like principal root. You know what I mean? But here's the crazy thing, and here's the crazy thing. If I ask you the question, like all written out, what are all the second roots of 25? Like if I write it all out in a sentence, what are all the second roots of 25? You would say both 5 and negative 5. But again, this symbol implies only the principal, you know, usually positive root. Okay, if there's 2 of them. Anyway, so I know I kind of dragged that out a little bit, but that was one of the big ideas of this whole lesson. Are there any real 4th roots of negative 16? No, there's no real square roots. There's no real 4th roots. You know what I mean? Think about it, and you'll understand. Is negative 5 a 3rd root of negative 125? That answer is yes, because think about it. So in other words, you can have a 3rd root of something negative, but you cannot have a 4th root of something negative, at least, and have it still be like real. And why? Because, you know, it's an even odd thing, you know. Think about it. So you cannot do even roots, 4th roots, 2nd roots, 6th roots of negative numbers. But you can. But look, it totally makes sense to have, you know, a 3rd root of negative 125, because look at this. Negative 5 to the 3rd power is in fact negative 125. Some roots are irrational. Well, duh, you've known that for years, like the square root of 7, you know, or the square root of 10, or the square root of 11, or the square root of 12, or the square root of 13, right? Square root of, yeah, that's why I just said that. Or the 4th root of 35. You know, I know you can do you can do a really clean 4th root of like 16, but not the 4th root of 35. Anyway, I'm going to skip over a lot of this, maybe all of it. The 4th roots. So I think maybe kind of I'll run through these really quick. The 4th roots of positive 81 would be both positive 3 and negative 3, because if you raise both of these to the 4th power, you get positive 81. Okay, but if I was just to write this using this symbol, the fourth root, see, once I put a 4 right here, now this is not a square root, it's a fourth root. So if I literally write it like this, what is the fourth root of 81? You're only going to say positive 3, and that's it. Because this symbol only implies the principal root, which again is usually the positive root. What are all the fourth roots of 0? I mean, 0. There's only one of them. And the fourth roots of negative 81, there are none. There's none real. And so the third roots of 64, well, there's only one, and it's positive 4, because 4 to the third power, 64. All the third roots of 0, well, just 0. And all the third roots of negative 64, there is one, and it's negative 4. And again, pause the video as you need to. Finding all the real roots. So, you know, I mean, okay, it's getting a little bit heavy with decimals and fractions. Oh well. It's the same concept. You know, what are all the real cube roots? So for these ones, I know these directions are kind of don't really stand out. But what are all the real third roots? Well, what number to the third power would equal 0.008? And I know decimals make it a little weirder, but turns out that it's 0.2. The 0.2 to the third power equals 0.008. How about, what do you think the third, all of the third, and again, there's only one, you know, you wouldn't also say negative 0.2. What are all the real third roots of negative 1,000, if there are any? You would say negative 10, after a little bit of, you know, pondering. How about 1 over 27? What do you think, like, the third root of 1 over 27 would be? Well, 1/3. Okay, 1/3 to the third power would get you 1 over 27. You know, it's just, and again, it's like there's not really much for me to go into depth. You know, hey, sometimes you just got to deal with fractions as they hit you, and decimals. How about all the real fourth roots of these guys? So what are all the real fourth roots? Well, guess what? You'd have to say positive 1 and negative 1. Both of these to the fourth power. Because remember, a lot of this is the differences between an odd root and an even root. Now, the fourth root of this, well, it's negative. So there's no real ones. You can't take like you can't take the square root of something negative, you know, and you can't take the fourth root. You can't take the sixth root. You can't take the eighth root of something negative, okay? But you can do that with like third roots and fifth roots and seventh roots. Even versus odd, baby. And then what are all the real fourth roots of 16 over 81? And maybe, you know what, I think I can, especially with this one, I can go a little bit more in depth. Treat the numerator and the denominator separately. Like, what's the fourth root of 16? And what's the fourth root of 81? You know, and it's going to be positive and negative. But treat them separately, and you get positive 2/3, but also negative 2/3, because 2 is the fourth root of 16, and 3, or negative 3, is the fourth root of 81. Okay? Now this I already covered, because I already talked about this. You know how if I asked you for what are all the fourth roots of 16, you would say 2 and negative 2. But this, as it's written, you would only say 2, because we're using that specific radical symbol. So here, remember, when you're using this symbol, you're only looking for like one answer, if there is one, if it's real. So what's the third root of negative 8? Third root of negative 8, that's going to be negative 2. Okay, because negative 2 times negative 2 times negative 2 is in fact negative 8. What's the square root of 0.04? Remember, we're only going with the positive answer here, like you've done for years. 0.2. Okay, and your calculator could help you out with some of this stuff, I bet. What is the fourth root of negative 1? There's no real answer. Again, just like there's no square root of negative 1, there's no real fourth root of negative 1. And then this, okay, whatever. So negative 2 squared is positive 4, and then the square root of that is 2, okay? I'm going to, again, it's on your screen, at least for a second. You can totally pause it and write this down. I am going to pick my battles in the times we are in. And I'm going to basically skip this and not emphasize it and hold you to it. But it is a thing. But anyway, last page. So what is a simpler form? Ooh, exponents. So the only other thing I would emphasize is, what the heck do you do with exponents? It's like the square root of 16. That's 4. Well, what? Oh, okay. Oh, gosh. Wow, I'm going to have to really be meticulous about what boxes I move and don't move. Oh my gosh, man. Okay. Well, the square root of 16, that's just what? That's just 4. Okay? What's the square root of x to the 8th power? Remember, you play with exponents usually differently. Okay? Again, we are not, let me spell this out, okay? I'm not asking you for the square root of 8. I'm asking you for the square root of x to the 8th power. In other words, what would you square to get x to the 8th power? Okay? Now I'll move all these for now, but I mean, I'm probably gonna. Again, I'm not emphasizing on all this absolute value stuff. I don't really care at the end of the day. So yeah, I'll leave this here, but man, ignore the absolute value. Okay, just the bottom line is the square root of 16 is 4. And the square root of x to the 8th is actually x to the 4th. Think about it. When you square x to the 4th, you get x to the 8th. All right, so maybe now your brain is in the right mindset here, okay? What's the third root of a to the not 6, a to the 6th power? Like, what would you raise to the 3rd power to get a to the 6th power? And what would you raise to the 3rd power to get b to the 9th? I'm just going to move this. Nope, it's this box, I guess. This is the answer. Okay, that's the answer. And you might be looking at this as like a division type thing with these powers, and you're right. 6 divided by 3 is 2. 9 divided by... just because of the nature of exponents. It's because of all the rules of exponents. But, Last example. The 4th root of x to the 8th. Like, what would you raise? What would you raise to the 4th power to get x to the 8th? Well, x to the 2nd, okay? X to the 2nd power. What would you raise to the 4th power to get y to the 12th? Again, in other words, what's the 4th root of y to the 12th? Well, y to the 3rd. And again, I don't care about the absolute value. I'm okay, I guess, with just y to the 3rd. And that's it for the lesson. But in case you want to go above and beyond, I'll just move all these boxes and maybe you can look at it on your own time or whatever. Maybe try to figure out what the absolute value is all about, especially with, I don't know don't know what you can do with that. I mean, a little bit. But, all right, people. Oh, you know what? Let me, hope you notice and stick around. I'll try to put in the directions, I guess, for this assignment. But why don't I just go ahead and scroll through the homework and maybe see if there's any hints or tips to give you. I don't know if this is exactly what the homework is going to end up looking like, but let's just go on that assumption. Again, look, find all the real square roots, if there are any. If there are any. Okay, because there might not be any real square roots to something. I wonder when that would happen. But you wanna give both the positive answer and the negative answer. Just like here, if there's more than one, you're going to say so. Find all the real, I mean, there might not be, I don't know, but, find all the real cube roots of each number. Find all the real fourth roots, if there are any, of each number, okay? And then here, once you start using these symbols, the radical symbol, you're only going to give the principal root. Like, spoiler alert, all the real square roots of 36 would be both 2 and, oh my God, what am I saying? Both 6 and negative 6. But the answer to 22 here is just going to be positive 6. And then once again, it says here use absolute value symbols when needed, but you can disregard that, and I'm not going to hold you to that. So, all right, that'll do it.